Industrial robotics is evolving rapidly. To meet growing demands, the robotics industry increasingly relies on offline programming, the process of programming, simulating, and validating robot motion in a virtual environment before deployment. Spatial's portfolio of SDKs gives developers the tools to build offline programming environments, as well as a wide range of robotic applications, managing the entire workflow from CAD data import and optimization to geometric modeling, collision detection, path planning, and high-performance browser-based 3D visualization. Together, our SDKs create a consistent foundation for robotics software, so developers can innovate faster without reinventing the fundamentals. Our AGM framework helps robotics developers go to market faster. It provides a ready-to-use 3D application foundation for desktop and web, with built-in features for file handling, undo and redo, selection, and command management. So you can focus on robotics innovation, not on rebuilding basic application infrastructure. Here we see a proof-of-concept robotic application built with AGM, where multiple spot welding robots are taught and simulated within the same environment. To achieve this, the software must also manage constraints, motion limits, and safety zones. To handle these interactions between robots and their environment, Spatial provides CDS, the Constraint Design Solver. CDS allows developers to define and solve complex geometric and logical relationships, supporting robotic joints, mechanical constraints, and motion validation in both 2D and 3D. An essential function in offline teaching is collision detection. AGM also embeds SPACD, a module that uses a proprietary data structure optimized for high-speed collision detection, even in large cells with multiple robots. By using the polyhedra option, SPACD can also perform near-miss analysis, offsetting robot geometry to check clearances at any specified distance from workpieces, tooling, or other robots. For accurate simulation and visualization, geometry also needs to be optimized for performance and manageability. That's where data prep comes in. Complex robotic environments can contain thousands of parts, many unnecessary for simulation. Data prep, an add-on to 3D interop, simplifies CAD models during import. It removes hidden bodies, identifies repeated instances, and filters small details, reducing model size by up to 95% while maintaining visual accuracy. The result? Lighter data, faster load times, and smoother digital twin performance. Once the data is prepared and optimized, the next step is bringing it to life in a fully interactive, web-based environment. With Hoops Communicator, you can build fully interactive digital twins accessible directly from a web browser. In this virtual factory, multiple robots perform different tasks: arc welding, spot welding, pick-and-place operations, and metrology inspection with probes, each displaying live operational states. Engineers can analyze performance, detect collisions, and share insights, all without building a single physical cell. Accessible anywhere, the browser becomes the collaborative workspace for robotic development and validation. Together, Spatial's SDKs form a unified foundation for robotic application development, so your team can focus on innovation, not infrastructure. That's why industry leaders in robotics and digital manufacturing build their software on Spatial technology. Get in touch today to discover how our solutions can help you create the next generation of 3D applications.